Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have two circles. Each circle is passing through the center of the other circle. This is the center of this circle, and this circle is passing through the center of this circle. This is the center of this circle, and we want to find out the area of this green shape. So first of all, I will explain what is a segment, what is a sector. Sector is the area that is bound by two radiuses and the arc that is included between those two radiuses. So the area of sector, this sector, sector A or B, is the green area. And the formula for finding out the area of this green sector, it is pi r square. When r is the radius of the circle, pi r square times the angle that is between the two radiuses divided by 360 degrees. In this specific case, the angle between those two radiuses is equal to 60 degrees. So the area of this sector in the green color equals to pi r square. R is the radius of the circle, pi r square times 60 degrees over 360 degrees. Okay, so this is the definition of a sector. That is actually the area that is bounded between two radiuses and the arc that is included between those two radiuses. And the area, the formula for the area is equal to pi r square times the radius between the two radiuses over 360 degrees. Okay, so this is the definition of a sector. And we also have another term that is segment. A segment is the area inside a circle that is bounded by a chord and an arc. So segment AB in the green color, it is actually the area that is bounded between arc AB and chord AB. Okay, again, segment is the area that is bounded by the arc and the chord. In this example, segment AB is the green area that is actually bounded by chord AB and arc AB. Okay, and the area of sector AB is equal the area of segment AB, the area of segment AB, the segment is bounded by arc AB and chord AB. The area of this segment AB will be equal to the area of sector AOB, the area of sector AOB, minus the area of triangle AOB. Okay? Again, the area of segment AOB equals to the area of sector AOB minus the area of triangle AOB. And we know that the area of the sector AOB will be equal to pi r square times 60 degrees over 360 degrees minus the area of this triangle will be equal to the area of segment AB. Okay, again, segment is the area that is bounded by arc AB and chord AB. Okay, a segment is the area that is bounded by arc and the segment that is attached to that arc inside a circle. And the area of a circle equals to the area of sector A or B, in this case, minus the area of triangle A or B. Okay? So, we start to answer to this question to find out the area of this green shape. First of all, we will define the center of this circle as point P, and we will define the center of this circle as point Q. Then we will define the first intersection point between those two circles as point A, and we will define the second intersection point of those two circles as point B. We will join points A and B by a straight line, and we will join points P and B by a straight line. Line segment PB is the radius of this circle because of the fact that it starts from point P and ends at point B, that is the point of the circle itself. Therefore, it is the radius of this circle, that is to say it equals to 5 units. I will mention that the radius of those two circles is equal to 5 units. Therefore, PB, that is the radius of this circle, equals to 5 units. We join points Q and B by a straight line. Line segment QB is the radius of this circle because of the fact that it starts from the center of this circle and ends at point B, that is the point of the circle itself. Therefore, it is the radius of this circle, that is to say it equals to 5 units. We join points P and A by a straight line. AP is also the radius of this circle because of the fact that it starts from the center of this circle and ends at point A, that is the point of the circle itself. Therefore, it is the radius of this circle, that is to say it equals to 5 units. We will join points A and Q by a straight line. And AQ is the radius of this circle because of the fact that it starts from the center of this circle and ends at point A, that is the point of the circle itself. Therefore, it is the radius of this circle, that is to say it equals to 5 units. So, actually, by joining the points, those points together, we created a rhombus. A rhombus is a quadrilateral that has 4 equal sides, and you can see that all the sides of rhombus A, P, B, Q are equal to each other. They are equal to 5 units. So I'll write it down. Actually, quadrilateral APBQ is a rhombus. I'll repeat again. Quadrilateral APBQ is a rhombus. A rhombus is a quadrilateral that all of its sides are equal to each other. We will join points A and B together by a straight line. AB is the first diagonal of rhombus APBQ, and we'll join points P and Q together by a straight line. So PQ is the second diagonal of rhombus APBQ, and PQ is the radius of this circle because of the fact that it starts from the center of the circle at point and ends at point Q, that is a point of the circle itself. Therefore, PQ is the radius of this circle, that is to say, it equals to 5 units. PQ equals to 5 units is the radius of this circle. So we have here two diagonals of rhombus APBQ, and the characteristics of the diagonals are as follows. The characteristics of diagonal of a rhombus are as follows. First of all, the diagonals of a rhombus are, they have two characteristics. The first characteristics of a diagonal or diagonals of a rhombus is that they are perpendicular to each other. The diagonals of a rhombus are perpendicular to each other. So here the diagonals of the diagonals of rhombus APBQ are perpendicular to each other. That is to say, all the angles here are right angles. We'll define the intersection point between diagonal AB and diagonal PQ as point M. And the second characteristics of a rhombus is that the diagonals of a rhombus are they bisect each other. I'll repeat again. The diagonals of a rhombus bisect each other. That is to say, PM equals to MQ, and AM equals to MB. AM equals to MB. Okay. So here, if we define PM as x, if PM equals to x, then MQ will be also equal to x. But we know that x plus x equals to PQ. X plus x equals to PQ. That is to say, x plus x is 2x, and 2x equals to PQ, but PQ equals to 5 units. It is the radius of this circle. PQ equals to 5, so from this equation we will derive that 2x equals to 5, 2x equals to 5. We'll divide this equation by 2 and we'll get that x equals to 5 over 2 units. So here x equals to 5 over 2 units, so I will substitute x by 5 over 2 units. And then also I will substitute x by 5 over 2 units. In the next step, we will focus on triangles, on 4 triangles. On triangle APM, we focus on triangle APM, and triangle AMQ, and triangle BQM, the right triangle, triangle BQM, and the right triangle, triangle PBM. On those 4 right triangles, we know that cosine, we define the angles here, this angle and this angle, this angle and this angle will be defined as angle theta. So cosine theta, all the angles here are defined as cosine theta. Cosine theta equals to 5 over 2 over 5. Okay, the cosine of all the angles here are defined as theta, and they equal to 5 over 2 over 5, here also 5 over 2 over 5, here also 5 over 2 over 5, and here also it is 5 over 2 over 5. So here 5 over 2 over 5 is 5 over 5 times 2. 5 over 5 is 1, so it is 1 over 2. So we found out that cosine theta equals to 1 over 2. Cosine theta equals to 1 over 2. And if cosine theta equals to 1 over 2, then theta equals to 60 degrees. So all the angles here are equal to 60 degrees. Okay, all the angles are equal to 60 degrees, and here angle APB equals to 60 degrees plus 60 degrees, that is to say it equals to 120 degrees. So we will focus on triangle APB. Triangle APB, and triangle AQB. On those two triangles, AP equals to AQ equals to 5 units. AP equals to AQ equals to 5 units. PB equals to QB equals to 5 units. And AB equals to itself. It is a common side that equals, it is a common side that belongs to both triangles. So AB equals to AB. It's a common side that belongs to both triangles. So actually we proved that triangle APB can go into triangle AQB according to side rule. Triangle APB congruent, this is the sign of congruent, to triangle AQB according to side rule. Okay. All sides of triangle APB congruent to all sides of triangle AQB. Therefore, those two triangles congruent to each other according to side rule. And from the fact that those two triangles congruent to each other, we will conclude that the area of triangle APB is equal to the area of triangle AQB. The area of triangle APB is equal to the area of triangle AQB because of the fact that if two triangles congruent to each other, then they also have the same areas. So triangle APB congruent to triangle AQB. Okay? So in the next step, we will calculate the area of sector APB. What is the area of sector APB? The area of sector APB, it is actually, it will be equal to pi r square times 60 degrees plus 60 degrees is 120 degrees over 360 degrees. I repeat again, the area of sector APB is equal to pi r squared times 120 degrees over 360 degrees. R equals to 5 units, r squared is 5 squared, 5 squared is 25, so the area equals to 25 pi, and 120 degrees over 360 degrees is 3. So we found out that the area of sector, the squared brackets here is the sign for the area, so the area of sector APB is equal to 25 pi over 3 square units, and the area, so I will define the okay, so it is 25 pi over 3 square units, and the area of triangle APB, the area of triangle APB or the area of triangle APB equals to the area of triangle AQB. So, in conclusion, first of all, we know that the area of triangle APB, the area of triangle APB equals to the area of triangle AQB. And what is the area of sector AQB? The area of sector AQB equals to here it is pi r squared times 60 degrees plus 60 degrees is 120 degrees over 360 degrees. I repeat again, the area of sector AQB equals to pi r squared times 120 degrees over 360 degrees. R equals to 5, so r squared is 25, and 120 degrees over 360 degrees is 1 over 3, so we found out that the area of sector AQB equals to 25 pi over 3 square units. The area of sector AQB equals to 25 pi over 3 square units, but the area of sector APB also equals to 25 pi over 3 square units. That is to say, the area of sector APB is equal to the area of sector AQB And we have already found out that the area of triangle APB is equal to the area of triangle AQB. So we will define the area of the triangle AQB and triangle APB is x. They are equal to each other, so both of the areas are equal to x square units. And what is the area of segment AQB? The area of segment AQB, this segment, the area of segment AQB, this segment will be equal to the area of sector APB minus the area of triangle APB. I'll repeat again. The area of segment AQB equals to the area of sector APB minus the area of triangle APB. So the area of sector APB equals to 25 pi over 3 minus the area of triangle APB. We define the area of triangle APB as x, so it is x. That is to say, the area of segment APB, the area of segment AQB equals to 25 pi over 3 minus x square units and what is the area of segment APB? This segment, the area of segment APB will be equal to the area of sector AQB minus the area of triangle AQB. I'll repeat again. The area of segment APB, the area of segment APB equals to the area of sector AQB minus the area of triangle AQB. But we have already found out that the area of sector AQB equals to 25 pi over 3 minus the area of triangle AQB, and according to our definition, the area of triangle AQB equals to x. In conclusion, we found out that the area of segment APB equals to 25 pi over 3 minus x square units, and it is exactly it's the area of segment AQB. The area of segment AQB is also equals to 25 pi over 3 minus x square units. So we'll conclude that the area of segment APB is equal to the area of segment AQB. Repeat again, we conclude that the area of segment APB equals to the area of segment AQB. So we can see here the area of segment APB equals to the area of segment AQB. That is to say, we can take the area of segment AQB and we will multiply it by 2 and we will get the area of the green shape, because those two areas are equal to each other. So we can take segment AQB, we will multiply it by 2 and we will get the area of the green shape. That is the area that is required in the question. Okay? So the area of segment APB equals to 25 pi over 3 minus x. X is the area of triangle AQB. So the only thing that is left to find is to find the area of triangle AQB, and then we will multiply this expression by 2 and we will get the area of the green shape. That area that is required, the area of the green shape. So what is the area of triangle AQB? So here we'll find out the base AB of triangle AQB. We will multiply it by the height MQ, we'll divide it by 2 and we'll get the area of triangle AQB. So we'll define AM will be equal to age, and we know that AM equals to MB. So after we will find out the value of age, we will multiply it by 2 and we will get the value of AB. AB will be the base of triangle AQB. We will multiply the base of triangle AQB by the height, that is MQ, that is 5 over 2. We'll divide it by 2 and we'll get the area of triangle AQB. So here we'll focus on triangle, the right triangle AQM. In the right triangle AQM, sinus 60 degrees equals to age over 5. Sinus 60 degrees is square root of 3 over 2, and it equals to age over 5. We will multiply this equation by 5, and we will get that age equals to 5 times square root of 3 over 2. But we know that AM equals to MB, so we'll multiply H by 2 in order to get the value of AB, the length of AB. So AB equals to 2 times H, and H is equals to 5 times square root of 3 over 2. So 2 times 5 times square root of 3 over 2. 2 over 2 is 1. So we found out that AB equals to 5 times square root of 3. So AB equals to 5 times square root of 3. AB is the base. And the area of triangle AQB will be equal to the base of the triangle that is AB times the eye that is MQ over 2. I'll repeat again. The area of triangle AQB equals to the base AB times the eye that is MQ over 2. So AB equals to 5 times square root of 3 units. Times MQ equals to 5 over 2. All divided by 2. 5 times 5 is 25. In conclusion, we found out that the area of triangle AQB the area of triangle AQB equals to 25 times square root of 3 over 4. So here we found out that the area of segment APB equals to 25 pi over 3 minus x. X is the area of triangle AQB, and the area of triangle AQB equals to 25 times square root of 3 over 4. So we have to multiply segment APB by 2 in order to get the area of the green shape. So we will multiply segment APB by 2 and we'll get that the area of the green shape will be equal to 2 times 25 pi over 3 minus 25 times square root of 3 over 4. So here we take out 25 as a common factor of this expression, and we get that 2 times 25. Inside the brackets we have here pi over 3, and here what is left from this expression after we took from it 25 as a common factor, what is left is actually square root of 3 over 4. So we actually found out 2 times 25 is 50, pi over 3 minus square root of 3 over 4 square units. So we found out that the area of the green shape equals to 50 times pi over 3 minus square root of 3 over 4 square units. We finished with the first method. In the next step I will present to you how to find out the area of this green shape according to the second method. Here we define the center of this circle as point P, the center of this circle is point Q, the first intersection point between those two circles is point A, and the second intersection point of those two circles is point B. We will join points A, P, AQ, QB, and PB by a straight line. We've already found out that they are equal to 5 units. All those line segments are equal to 5 units. We already found out in the first method. PQ, it is actually the radius of this circle, that is to say it equals to 5 units. So as you can see here, triangle APQ is an equilateral triangle, that is to say all of its angles are equal to 60 degrees. The triangle PQB also equals to, it is also equilateral triangle because all of its sides are equal to each other. Therefore, all of its angles will be equal to 60 degrees. And triangle APQ is congruent to triangle PQB according to side rule. I write it down. Triangle APQ congruent to triangle PQB according to side rule. All the sides of triangle APQ are equal to 5 units, and all the sides of triangle PQB are also equal to 5 units. So those two triangles can go into each other. Therefore, the areas of those two equilateral triangles will be equal to the area of one triangle times 2, because the areas of those two triangles are equal to each other. So actually the area of those two triangles will be equal to the area of triangle APQ times 2. This is the area of those two triangles, the area of triangle APQ times 2. And if we add to the area of those two triangles the area of the 4 segments AQ, BQ, PB, and AP, we will get the area of the green shape. So we can write down that the area of the green shape will be equal to 2 times the area of triangle APQ, the equilateral triangle, plus the area of segment AQ, plus the area of segment QB, plus the area of segment PB, plus the area of segment AP. I'll repeat again. The green area is equal to 2 times the area of the equilateral triangle, triangle APQ, plus the area of segment AQ, plus the area of segment QB, plus the area of segment PB, plus the area of segment AP. Okay? And we know that triangle APQ is congruent to triangle PQB, therefore they also have the same areas. So I write down that triangle APQ, the area of triangle APQ the area of triangle, the equilateral triangle, triangle APQ equals to the area of triangle PQB. Again, the area of those two triangles are equal to each other because they congruent to each other. And what is the area of segment AQ? Actually, the area of segment AQ will be equal to the area of sector APQ the area of sector APQ minus the area of triangle APQ. I repeat again, the area of segment AQ will be equal to the area of sector APQ minus the area of triangle APQ. And what is the area of sector QB? The area of segment QB? The area of segment QB the area of segment QB will be equal to the area of sector PQB minus the area of triangle PQB. Okay, I repeat again. The area of segment PB will be equal to the area of sector PQB minus the area of triangle PQB. As you can see here, triangle APQ is the area of triangle APQ equals to the area of triangle PQB. So those two areas are equal to each other, and we have the area of sector APQ and the area of sector PQB. Okay, the area of sector APQ will be equal to pi r squared times 60 degrees over 360 degrees. As you can see here, actually, okay, so the area of sector APQ will be equal to pi r squared over 6. And the area of sector PQB will be also equal PQB. The area will be also equal to pi r squared over 6. So the area of sector APQ is equal to the area of sector PQB, and the area of triangle APQ equals to the area of triangle PQB. So if we define the area of sector APQ, so it actually equals to pi r squared over 6. So it will be equal to pi r squared over 6 minus the area of triangle PQB that we will define as x. So the area of segment QB equals to pi r squared over 6 minus x, and the area of segment AQ will be equal to pi r square minus x. So you can see r equals to 5, so pi r square over 6 minus x equals to pi r square over 6 minus x. That is to say, we can derive from it that the area of segment AQ equals to the area of segment QB. Again, the area of segment APQ equals to pi r square over 6 minus x, and the area of triangle PQB also equals to pi r square over 6 minus x, r equals to 5. So pi r square over 6 minus x equals to pi r square over 6 minus x. Therefore, the area of segment AQ equals to the area of segment QB. Okay? So, the area of segment AQ, this area equals to the area of segment QB. Okay? And if we continue to calculate the area of segment PB and the area of segment AP, we will get the same results. The area of those two segments will be also equal to pi r square over 6 minus x. Here also the area is pi r square over 6 minus x. So actually we found out that the areas of those four segments AQ, QB, and PB and AP are all equal to each other. All those areas are equal to each other. Therefore, in order to find out the area of the green shape, we will multiply 2 times the area of triangle APQ, and we will add to it 4 times the area of segment AQ. Why? Because the 4 segments are equal to each other, and they are all equal also to the area of segment AQ. So we will multiply the area of segment AQ by 4, and we will get the green area. So I'll write it down. So the green area will be equal to 2 times the area of triangle APQ plus 4 times the area of segment AQ. We'll repeat again. The green area will be equal to 2 times the area of the equilateral triangle APQ plus 4 times the area of segment AQ. Okay? So we'll find out the area of triangle APQ and we will multiply it by 2 in order to find out the area of those two equilateral triangles. We define the intersection point between the first diagonal and the second diagonal as point M. We define AM as H. In triangle AMQ, sinus 60 degrees equals to edge over 5. I repeat again, in triangle AMQ, sinus 60 degrees equals to edge over 5. Sinus 60 degrees is square root of 3 over 2. We'll multiply this equation by 5, and we'll get that edge equals to 5 times square root of 3 over 2. So the height of triangle APQ equals to 5 times square root of 3 over 2, and the area of triangle APQ will be equal to the base of the triangle, that is PQ, times the height, that is AM, over 2. Okay, I repeat again, the area of triangle APQ equals to the base of the triangle, that is PQ, times the height, that is AM, over 2. And PQ equals to 5 units, it is the radius of this circle, times AM. AM is the height, that is equals to 5 times square root of 3 over 2, or divided by 2. So the area of triangle APQ equals to 25 times square root of 3 over 4. So this is the area of triangle APQ, and we have to multiply the area of triangle APQ by 2 in order to get the area of those two equilateral triangles. So 2 times the area of triangle APQ is 2 times 25 times square root of 3 over 4. And the area of segment AQ equals to the area of sector APQ. We have already found out that the area of sector APQ equals to pi r squared over 6 minus the area of triangle APQ, and we have already found out that the area of triangle APQ equals to 25 times square root of 3 over 4. Okay, so write it again. the area of segment AQ equals to the area of sector APQ minus the area of triangle APQ I repeat again, the area of sector AQ equals to the area of segment AQ equals to the area of sector APQ minus the area of triangle APQ. And we have already found out that the area of sector APQ equals to pi r squared over 6, and the area of triangle APQ equals to 25 times square root of 3 over 4. R equals to 5, so r squared is 25, so it is actually equals to 25 pi over 6, and the area of segment AQ will be equal to 25 pi over 6 minus 25 square root of 3 over 4. Again, the area of segment AQ equals to 25 pi over 6 minus 25 times square root of 3 over 4. So here, again, the area of segment AQ equals to 25 pi over 6 minus 25 times square root of 3 over 4. And we have the green area equals to 2 times the area of triangle APQ, that is actually 2 times 25 times square root of 3 over 4, plus 4 times the area of triangle, the area of segment AQ, and the area of segment AQ equals to 25 pi over 6 plus minus 25 square root of 3 over 4. In conclusion, the green area equals to 2 times 25 is 50 times square root of 3 over 4 plus 4 times 25 is 100, so it is 100 pi over 6. 4 times 25 it is 100, so it is minus square root of 3 over 4. So actually that is the green area. So here we will divide the numerator and the denominator by 2, and we'll get that 100 over 2 is 50, so it is 50 pi over 3, and here we have 50 times square root of 3 over 4 minus 100 times square root of 3 over 4 is minus 50 times square root of 3 over 4. So the green area equals to 50 pi over 3 minus 50 times square root of 3 over 4, or the green area equals to, here we take 50 out of these expressions, and we get inside the brackets what is left after we took 50 of this expression. From this expression, what is left, it is actually pi over 3, and what is left from this expression after we took from it 50 as a common factor, what is left, it is actually square root of 3 over 4. So we found out that the area of the green shape according to the second method equals to 50 times pi over 3 minus square root of 3 over 4. And this is the question, the answer to this question according to the second method. So in both methods we found out that the area of the green shape equals to 50 times pi over 3 minus square root of 3 over 4 square units. So in the next step I will summarize the lecture. Actually we wanted to find out the area of this green shape, and in the first method, I'll repeat again, we have here two circles. One, each circle is passing through the center of the other circle. The radius of those two circles is equal to 5 units, and we want to find out the area of this green shape. So first of all, I explain to you what is a sector. A sector is the area that is bounded by two radiuses and the arc that is located between those two radiuses. So the green shape is the sector AOB. Sector AOB is the area that is bounded between this radius and the arc AB. So it is the green shape, and the area of this sector, sector AOB, equals to pi r square. R is the radius of this circle times the angle that is between the two radiuses. Again, pi r square, r is the radius of this circle, times the angle that is between those two radiuses over 360 degrees is equal to the area of sector AOB. Again, pi r square over 60 degrees over 360 degrees is equal to the area of this green sector, sector AOB. Okay. Then I explained you what is segment. Here, segment is the area that is bounded between arc AB and chord AB. Again, the area that is bounded by arc AB and chord AB is the segment AB in the green color. And the area of this segment AB, is calculated according to the formula that the area of sector AB equals to the area of segment AB equals to the area of sector AOB minus the area of triangle AOB. Again, the area of segment AB equals to the area of sector AOB minus the area of triangle AOB. Okay? So this is the definition of a segment, and the area of the segment is the area of sector AOB minus the area of triangle AOB. Okay? Then we connected together points P and B by a straight line, points B and Q by a straight line, points A and Q by a straight line, and points A and P by a straight line. Okay, so we have here PB is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point P, and ends at point B, that is the point of the circle itself, therefore it is the radius of this circle, that is to say it equals to 5 units. QB is also the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point Q and ends at point B. AQ is also the radius of this circle for the same reason. It starts from the center of the circle and ends at point A, that is the point of the circle itself. Therefore it is the radius that equals to 5 units. and AP is also the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point P, and ends at point A, that is the point on the circle itself. Therefore, it equals to 5 units as the radius of this circle. So actually, if I connected the points together with a straight line, we created here quadrilateral AP BQ, and quadrilateral AP BQ is a rhombus. A rhombus is a quadrilateral that all of its sides are equal to each other, and you can see AP equals to PB equals to BQ equals to AQ equals to 5 units. So we have here rhombus AP BQ, and okay, so quadrilateral AP BQ is a rhombus. All the sides of a rhombus are equal to each other. In our case, they are equal to 5 units. And the diagonals of a rhombus, here we connected points A, B. AB is the first diagonal, PQ is the first diagonal of rhombus AP BQ. And the characteristics of diagonals of a rhombus are as follows. The diagonals of a rhombus are perpendicular to each other. So the diagonal AB is perpendicular to the diagonal PQ, that is to say, all the angles here are right angles. And the second characteristic of a rhombus is that the diagonals of a rhombus bisect each other. That is to say, AB bisect PQ and PQ bisect AB. AB bisect PQ, that is to say, PM equals to MQ. PM equals to MQ, and PQ bisect AB, that is to say AM equals to MB. Okay? So here PM equals to MQ. So if we define PM as X, then MQ will be also equal to X. That is to say PQ equals to X plus X. That is to say PQ equals to 2X. But PQ is also the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point P, and that's at point Q, that is the point of the circle itself. Therefore, PQ is the radius of this circle, that is to say it equals to 5 units. We know that PM plus MQ equals to PQ. So PQ equals to X plus X. But PQ equals also to 5 units because it is the radius of this circle. So we got here that 2x equals to PQ, that equals to 5 units. That is to say 2x equals to 5 units. We divided this equation by 2 and we got that x equals to 5 over 2 units. So PM equals to 5 over 2 units and MQ also equals to 5 over 2 units. Okay? Then we actually focused on those 4 right triangles. We have here 4 right angles inside rhombus APBQ. We have 4 right triangles. We focused on those all 4 right triangles, and we know that the value of cosinus in all those 4 right triangles, if you focus on this angle in the right triangle AMQ, and you focus on this angle on the right triangle QBM, and if you focus on this angle on the right triangle PMQ, and if you focus on this angle on the right triangle APM, we will find out that the cosinus here equals to 5 over 2 over 5. In all those 4 right triangles, the cosinus of those angles, those 4 angles, is equal to 5 over 2 over 5. Okay? The cosinus of all those 4 angles inside those 4 right angles is equal to 5 over 2 over 5. That is to say it equals to 5 over 5 times 2, or cosinus theta equals to 1 over 2. So if cosinus theta equals to 1 over 2, it means that theta equals to 60 degrees. So we found out that all 4 angles, angle BPM equals to 60 degrees, angle APM equals to 60 degrees, angle BQM equals to 60 degrees, and angle AQM also equals to 60 degrees. All those angles are equal to each other, and they are equal to 60 degrees. Okay? Then what is the area of sector APB? The area of sector APB, this sector is equal to the area of, actually it is the area of segment APB No, first of all, we focused on sector APB, the area of sector APB. This sector APB equals to pi r squared times 120 degrees over 360 degrees. Okay, so the area of sector APB equals to pi r squared times the angle between those two legs, that is 120 degrees over 360 degrees. Again, the area of sector APB equals to pi r squared times 120 degrees over 360 degrees. R equals to 5 units, so r squared is 25. So here we will have 25 pi times 120 degrees over 360 degrees is 25 pi over 3 square units. So we found out that the area of sector APB equals to 25 pi over 3 square units. And what is the area of sector APB? The area of sector APB, this sector will be equal to the area of sector APB equals to, so we already found out that the area of sector APB equals to 25 pi over 3 square units. And what is the area of sector AQB? The area of sector AQB equals to the area pi r squared. The area of sector AQB equals to pi r squared times 120 degrees over 360 degrees. Again, the area of sector AQB also equals to pi r squared times 120 degrees over 360 degrees. Okay, so those two sectors, sector AQB is equal in its area to sector AQB is equal in its area to sector APB. Okay, sector APB equals to sector AQB. Again, the area of sector AQB equals to pi r squared times 120 degrees over 360 degrees. That is to say, the area of sector AQB equals to 25 pi over 3, and the area of sector APB also equals to 25 pi over 3 square units. That is to say, the area of sector APB equals to the area of sector AQB. And then we have triangle APB. So sector APB equals to sector AQB. what is the area of segment AQB? The area of segment AQB, this segment, will be equal to the area of sector APB minus the area of triangle APB. Again, the area of sector AQB equals the area of segment AQB equals to the area of sector APB minus the area of triangle APB. Okay? So the area of segment AQB equals to the area of sector APB, that is 25 pi over 3, and we defined the area of triangle APB as x. Okay? And actually, here we focused on triangle APB and triangle AQB. In those two triangles, AP equals to AQ equals to 5 units, AP equals to AQ equals to 5 units, PB equals to BQ equals to 5 units, PB equals to QB equals to 5 units, and AB equals to itself. It is a common side that belongs to both triangles. Therefore, those two triangles can go into each other. And because of the fact that those two triangles can go into each other, they also have the same areas. That is to say, the area of triangle APB equals to the area of triangle AQB. Those two triangles have the same areas. And the area of segment AQB equals to the area of sector APB, that is 25 pi over 3, minus the area of triangle APB. We defined the area of triangle APB as x, so the area of segment AQB equals to 25 pi over 3 minus x square units. And then, what is the area of segment APB? The area of segment APB equals to the area of segment AQB. Again, the area of segment APB equals to the area of sector AQB minus the area of triangle AQB. And the area of sector AQB equals to 25 pi over 3 square units. And the area of triangle AQB equals to x. Why? Because the area of triangle APB is equal to the area of triangle AQB. And if the area of triangle APB is defined as x, again, we define the area of triangle APB as x, so the area of triangle AQB will be also equal to x because of the fact that they have the same areas. So the area of segment APB that equals to the area of sector AQB minus the area of triangle AQB equals to 25 pi over 3 minus x. Okay? And the area of segment APB also equals to 25 pi over 3 minus x. That is to say, the area of segment APB, equals to 25 pi over 3 minus x, and the area of segment AQB also equals to 25 pi over 3 minus x. Okay, so from those two statements we derive that segment APB equals to segment AQB. Okay, and then because of the fact that segment APB equals to segment AQB, segment APB equals to segment AQB, we can calculate the area of one segment. We will multiply it by 2 and we will get the green area. Okay, and what is the area of segment APB? The area of segment APB equals to the area of sector AQB minus the area of triangle AQB. And we already found out that the area of sector APB equals to 25 pi over 3, and the area of triangle AQB equals to x according to our definition. Then we defined AM as edge, and we focused on the right triangle AMQ. Here sinus 60 degrees equals to edge over 5. We know that sinus 60 degrees equals to square root of 3 over 2, and it equals to edge over 5. So we multiplied this equation by 5, and we found out that edge equals to square root of 3 times 5 over 2, and AM equals to MB, so MB will be also equals to edge. So we multiply AM by 2, and we will get the length of AB. So AB equals to edge times 2. Edge times 2 is 2 times 5 times square root of 4 over 2. Again, edge is 5 times square root of 3 over 2. And 2 times edge is 2 times square root of 3 times 5 over 2. 2 over 2 is 1. So we found out that AB equals to 5 times square root of 3. AB equals to 5 times square root of 3. And what is the area of triangle AQB? The area of triangle AQB equals to the base of the triangle, that is AB, times the height, that is MQ, over 2. Again, the area of triangle AQB equals to the base, that is AB, times the height, that is MQ, over 2. AB equals to 5 times square root of 3. QM equals to 5 over 2, all divided by 2. So the area of triangle AQB equals to 5 times 5 is 25. So we have here in the numerator 25 times square root of 3 over 4. 2 times 2 is 4. So the area of triangle AQB equals to 25 times square root of 3 over 4 square units. And the area of segment APB equals to the area of segment APB equals to the area of sector AQB, that is actually 25 pi over 3, minus the area of triangle AQB, that is actually equals to 25 times square root of 3 over 4. Therefore, the area of segment AQB, that equals to the area of sector AQB minus the area of triangle AQB, equals to 25 pi over 3 minus 25 square root of 3 over 4, and 2 times the area of segment APB equals to the green shape. That is to say, the green shape equals to the area, 2 times the area of segment APB, that is actually 25 pi over 3 minus 25 times square root of 3 over 4. So here we took 25 as a common factor out of these two expressions, and inside the brackets from this expression we left with pi over 3, and from this expression after we took from it 25, we left only with square root of 3 over 4. 2 times 25 is 50, so in conclusion we found out that the area of the green shape equals to 50 times pi over 3 minus square root of 3 over 4 square units. This is according to the first method. And then we also found out the area of the green shape according to the second method. The area of the green shape according to the second method. Here we actually connected points A and P, A and Q, Q and B, B and P. All those line segments are equal to 5 units. We created here 2 equilateral triangles. Triangle AQP and Q is equilateral triangle, all of its sides are equal to 5 units, and triangle BQP also is equilateral triangle. Okay? And what is the area of the green shape, and because of the fact that triangle AQP is congruent to triangle PBQ according to side rule, those two sides are equal to each other. This is equals common side, and EQ equals to BQ equals to 5 units, so those two triangles can go into each other according to side rule, and because of the fact that those two equilateral triangles can go into each other, they also have the same areas. So we can calculate the area of one triangle and multiply it by 2, and in this way we will get the area of those two triangles. So the area of the green shape equals to 2 times the area of triangle APQ, 2 times the area of triangle APQ, that is the area of those two triangles, plus the area of segment AQ, plus the area of segment BQ, plus the area of segment BP, plus the area of triangle, plus the area of segment PA. Okay? And we know that the area of triangle APQ is equal to the area of triangle BPQ because they can go into each other. So what is the area of segment AQ? The area of segment AQ equals to the area of sector APQ minus the area of triangle APQ. Again, the area of sector AQ equals to the area of segment AQ equals to the area of sector PAQ minus the area of triangle PAQ. The area of segment AQ equals to the area of sector APQ minus the area of triangle APQ. And the area of sector APQ is equal to pi r squared times 60 degrees over 360 degrees. That is to say it equals to pi r squared over 6. So in conclusion, we found out that the area of segment APQ equals to pi r squared over 6 minus x, because we defined the area of triangle APQ as x. So the area of segment AQ equals to pi r squared over 6 minus x square units. And the area of segment QB, the area of this segment, equals also to the area of sector PBQ minus the area of triangle PBQ. Again, the area of segment QB equals to the area of sector PQB minus the area of triangle PQB. And the area of sector PQB, this sector, equals to pi r squared times 60 degrees over 360 degrees. That is to say it equals to pi r squared over 6. And the area of triangle PBQ, we already found out that the area of triangle PBQ equals to the area of triangle APQ. Again, the area of triangle PBQ equals to the area of triangle APQ, and we define the area of triangle PBQ as x. So we define the area of triangle APQ as x. Therefore, the area of triangle PBQ will be also equal to x. So in conclusion, we found out that the area of segment QB equals to pi r squared minus 6, exactly as the area of segment AQ. So we can write down that segment AQ equals to segment QB. And if we continue to calculate the areas of segment AP and PB, we will get that they also have the same areas of segment AQ and segment QB. Therefore, in order to find out the area of the green shape, we will multiply 2 times the area of the equilateral triangle APQ, and we will add to this area 4 times the area of triangle AQ, because of the fact that the area of those 4 segments AQ, BQ, PB and AP, they are equal to each other. So if we multiply the area of segment AQ by 4, we will get the area of those 4 segments. And therefore we actually found out that the area of the green shape equals to 2 times the area of the equilateral triangle APQ plus 4 times the area of segment AQ. And what is the area of triangle AMQ? The area of triangle AMQ, here we defined AM as H, and here sinus 60 degrees equals to H over 5. Sinus 60 degrees equals to H over 5 in triangle AMQ. Sinus 60 degrees is equal to 3 over 2, and we multiplied this equation by 5, and we got that H equals to square root of 3 over 2 times 5. Okay, so we have the height of the triangle, the equilateral triangle AQP, and the base PQ times the height AM, that is H, will give over 2, it will give us the area of triangle APQ. Again, the area of triangle APQ equals to PQ, that is the base, times AM, that is the height, over 2. PQ equals to 5 units. The height H equals to AM, that equals to H, that equals to square root of 3 over 2, all divided by 2 is the area of triangle APQ. The equilateral triangle APQ. 5 times 5 is 25, so in the numerator we have 25 times square root of 3, and 2 times 2 is 4, so in conclusion the area of triangle APQ equals to 25 times square root of 3 over 4 square units. So we have the area of triangle APQ, and 2 times the area of triangle APQ will give us the area of those two triangles. So it is 2 times the area of triangle APQ is 25 times square root of 3 over 4. Those are the areas of those two triangles, plus 4 times the area of segment AQ. And what is the area of segment AQ? The area of segment AQ equals to the area of sector APQ minus the area of triangle APQ. And we have already found out that the area of sector APQ equals to pi r square over 6. R equals to 5, so it is 5 square is 25. So the area of sector APQ is 25 pi over 6 minus the area of triangle APQ. We have already found out that the area of triangle APQ equals to 25 times square root of 3 over 4. So in conclusion, the area of segment AQ equals to 25 pi over 6 minus 25 times square root of 3 over 4 square units. And again, the area of segment AQ equals to 25 pi over 6 minus 25 times square root of 3 over 4 square units. And in order to find out the area of the green shape, we will add the area of the two triangles, that is actually 50 times square root of 3 over 4 times 4 times 4 times the area of segment AQ. Again, the area of the two triangles, that is two quadrilateral triangles, that equals to 50 times square root of 3 over 4 times 4 times the area of segment AQ. And 4 times the area of segment AQ is 4 times 25 is 100 times pi over 6 minus 4 times 25 is minus 100 times square root of 3 over 4 minus 100 times square root of 3 over 4. This is the green area. And here we have 50 times square root of 3 over 4 minus 100 times square root of 3 over 4 is minus 50 times square root of 3 over 4. And here we have minus 100 over 6. We divided both the numerator and the denominator by 2, and we got that 100 over 2 is 50, and 6 over 2 is 3. So in conclusion, this expression equals to 50 pi over 3 plus minus 50 times square root of 3 over 4. Here we took 50 a second factor out of those two expressions, and we got here what is left from this expression after we took from it 50, what is left is pi over 3, and what is left from this expression after we took from it 3, what is left from it is minus square root of 3 over 4. So the area of the green shape according to the second method equals to 50 times pi over 3 minus square root of 3 over 4 square units. So in both methods we found out that the area of the green shape equals to 50 times pi over 3 minus square root of 3 over 4 square units. Okay, thank you very much.